Hi and welcome to this latest video of inspiration and expiration. So in this video we are going to talk about the mechanism of inspiration and expiration. Alright, so for that you need to know that there is lungs, and in between the lungs and thoracic cavity there is one space that is called pleural space, and then after this is this is pulmonary, and this is lungs, and this is intrapleural space, and this is thoracic cage. Now what happens, generally the pressure outside in atmosphere is 760 mm of Hg. All right, so what happen if the same pressure is inside the pulmonary or in our lungs, that is 760 mm of Hg, we can also call it as 0 mm of Hg. Why? Because there is no difference between atmospheric pressure and pressure inside our lungs. So we do consider around true pressure, and around true pressure everything will run. Alright. So first thing is intrapulmonary pressure. Intrapulmonary pressure. And this ranges from -1 to +1 mm of Hg. And here -1 I mean that is 759 mm of Hg, means just one unit down from the atmospheric pressure, and +1 means 761 mm of Hg if the outer atmospheric pressure is 760 mm of Hg. So I think I could make clear that what is this +1 and -1 means. All right, and then after there is intrapleural pressure. All right, so this is the pressure between the parietal and visceral pleura. So parietal pleura touches the outer sides thoracic cage, and this visceral pleura touches the lungs of our body. Means viscera means organ. All right, so internal organ. So the space between this two parietal is called parietal space. All right, and the pressure range between this is -2 to -8 mm of Hg. All right, and it is always in minus. Why? If it comes even if 0, then lung might collapse. So why? Because there is one property of lungs that is called elasticity. So due to elasticity, lung is continuously trying to get collapsed. All right, but due to negative intrapleural pressure, the lungs is not collapsing. So the intrapleural pressure is always minus, always in negative values. All right, so now you do know the two concept. If the intrapleural pressure is -1, there is inspiration. If there is +1, that is expiration. And intrapleural pressure is always in negative. Now how this negative pressure is maintained? So there is one thing. First one is this thoracic cage. So when it pulls itself outside, so what happens, this volume tries to increase. So there is very Boyle's law, we do all know, I think. So what was that pressure and volume is always constant. So if we increase the volume, the pressure will increase, for pressure will decrease. All right, so as the in this thoracic case try to expand, it is trying to expand the volume, so pressure immediately changes to negative value. All right, so it becomes further negative. So as to maintain this negative pressure, our lungs also expand. So what happened, so as the pressure further becomes negative, our lungs just tries to expand as well. So it comes from +1 to -1, so that our lungs, so that we do inspire. All right, so outer atmospheric pressure pulls the air inside of our lungs. So I hope you could understand what is actually happening. All right, so there are further terms to define different pressure. So the pressure difference between these two. All right, this is given a term that is transpulmonary pressure. And what is it? It is the difference between pulmonary pressure and intrapleural pressure. All right. So we do give pulmonary minus P intrapleural space. All right. So for example, in normally we don't expire, means there is normal condition that there are neither inspiration nor expiration, so that is 0. All right. And at that time around minus 4 mm of Hg is maintained in intrapleural space. So we do get plus 4 mm of Hg. So what does this plus 4 mm of Hg denotes? That our lungs can easily expand, means there is positive transpulmonary pressure, and positive transpulmonary pressure helps our lung easily to expand because there is positive side. Right. Okay, so second pressure which I was talking about is the pressure difference between uh, intrapleural space and the atmospheric pressure, and this pressure is called transthoracic pressure. So that is the difference between the intrapleural space pressure, intrapleural pressure, and that is atmospheric pressure. So it is the difference between pressure inside the intrapleural space and the intra pressure of the atmosphere. So the intrapleural space is around minus 4 mm of Hg, and the pressure in the atmosphere is taken as 0 because we take the reference of atmospheric pressure. So minus 4 mm of Hg minus 0 is gives us minus 4 mm of Hg. So the general values of this transthoracic pressure is around minus 4 mm of Hg. One more pressure is there, that is between these two. All right, and that is called trans-respiratory pressure, and it signifies what is actually happening. All right, so if P pulmonary means pressure inside our lung is 0 mm of Hg, and outside is also 0 mm of Hg. P pulmonary is P atmospheric. All right, so this is 0, means there is no difference. All right, so at no difference what will happen, we do neither inspire nor inspire. All right, but if this trans-respiratory pressure, for example the pressure inside our lung is minus 1, and the pressure of outside is always taken as negative 0. All right, so minus 0, so we do get minus 1. So what does this minus 1 mm of Hg signifies is that we are in the process of inspiration, because inside the lungs there is negative pressure. So air tries to flow from higher pressure to lower pressure. So at this time we are inspiring. Then same condition during expiration, the pressure outside is always taken as 0, and inside our lungs is plus 1. So plus 1 minus 0, that will be plus 1. So at this time the pressure inside our lung is more than the outside. So what will happen, we will expire. So trans-respiratory pressure is a good indicator that what is happening at the current moment. And intrapleural pressure signifies uh, different pathological condition. For example, if there is higher pressure than 0, means it is not to be generally minus 2. So during edema, if there is fluid accumulation in this, or pneumothorax, if you are stabbed with uh, a knife, then it changes from negative to either positive or 0, which gives us idea that lung is in the condition of pneumothorax, means our lung has just gone from this to like this. And once lungs get collapsed, it is not very easily to expand. So to expand also there is a minimum criteria that alveoli should be at this much position. All right, so there are different factors which represents what will happen. It's elasticity or compliance. For example, surface tension. So if the surface tension inside the lungs is more, that will try to just decrease the surface area, because surface tension always tries to decrease the surface area. All right, and then after gravity also plays one role. So what happens, gravity tries to pull the lungs. So at the base it is trying to pull. So what will happen, as it is trying to pull, the volume will decrease. So again Boyle's law, if the volume is decreased, pressure will be increased at this position. At the apex, what will happen? Again, gravity will try to pull this. So as this will pull, the volume over here will increase. So if the volume will increase, what will happen? Pressure decrease. So that is the reason we do have higher pulmonary ventilation at the apex of lung. All right, so these two things there, and then there is presence of surfactants. Then after elasticity, if the lung is not elastic, it has become plastic, means it is not trying to collect coastal, it is not trying to reseal itself, then also there will be problem. So you know or not, I don't know, there is one thing, see, during inspiration we need energy, so that coastal cartilage pulls and we do inhale. But for expiration we don't need, because there is elasticity in lungs itself, so that by elastic force itself the lungs regain minus pressure. All right, so we do expire easily. So there is elasticity in the lungs which help in passive expiration, means there is no requirement of energy for expiration, but for inspiration we do need energy. So that is one thing. And what do I tell? Elasticity of the lung, and then after surface tension, then after presence of surfactant, and then after gravity. So these are the factors which plays major role in inspiration and expiration. And if there is different condition like pathological condition, these pressures might be changed. So these pressures gives us idea what is the condition of our lung. So there are mainly two pressure: intrapulmonary pressure and intrapleural pressure, and then after atmospheric pressure. So if you have these three pressures idea, then there is extra three pressure which is from their difference. So one is transpulmonary, means it is the difference between, take just uh, in this figure, take left minus, sorry, take right minus left. So this is in right side, so right minus left, that is transpulmonary pressure. And again take right and subtract left, so that is transpleural pressure. And then after there is transrespiratory, so take alveoli minus atmosphere. So this is a general idea how can you calculate those things, but main the idea is this. So I hope this video might be helpful for you. If this is helpful, please uh, share it. Thank you.